Finding target 18 says I can calculate the mean, variance, and standard deviation of a set of data. So there are two problems in this video. One of them is calculating the mean, variance, and standard deviation for a set of data where we don't really need to use frequency information. This is sort of a simpler, more straightforward type of problem. The problems that you are more likely to see are going to be the more complicated problems where you're given frequency information for each data point. So maybe the data point 1 happens 12 times and the data point 7 happens 15 times, and you're going to have to think about sort of how to adapt this strategy when you do have that frequency information. For this first problem though, let's just explore a simpler situation. So here we have a spinner and there are 5 different equal wedges. There's 1, there's 2 3s, there's a 6, and there's a 7. And the question asks you to find the mean, variance, and standard deviation for the numbers on the spinner. So to calculate the mean, when you're just given a set of data without special frequency information, to calculate the mean, all you have to do is add up the numbers and divide by the number of numbers that there are. So in this case, to find our mean, we have to take all of our numbers and add them up, and then divide by the number of numbers there are, which is 5. So if we add all of this up, we get, let's see, 20 over 5, which is 4. So in this problem, our mean is going to be 4. Now, the variance and the standard deviation are measures of spread, how spread out the data is. And the way that we sort of calculate how spread out the data is we think about how far each data point is away from the mean. So that's what a deviation is. It's when you take a data point and you subtract off the mean from it. So here, if we do 1 minus 4, we get -3. If we do 3 minus 4, we get -1. 3 minus 4 is -1. 6 minus 4 is a +2. Whoops. And 7 minus 4 is a +3. Now, if we think about how we might want to find a measurement of spread, you might want to just find the average of these deviations, like the average distance away from the mean a data point is. The problem is that if you were to do that, if you were to find the average of all these numbers, you just end up getting out 0. And so that's not really going to tell you anything about, sort of on average, how spread out is the data. So what we do instead is we look at the squared deviations. We find the average of those. So let's find all of our squared deviations. -3 squared is 9, -1 squared is 1, -1 squared is 1, 2 squared is 4, and 3 squared is 9. And the way that we're going to define our variance is it's going to be the average of the squared deviations. So it'll be 9 plus 1 plus 1 plus 4 plus 9 all over 5. And if you added all these up, you're going to end up getting, let's see, 9 and 1 is 10, here's another 10, so we're up to 20. So we have a total of 24 on the top and 5 on the bottom. And if we use our calculators, we end up getting 4.8. Now, the standard deviation is always going to be the square root of the variance. So standard deviation is going to be the square root of 4.8. And that's about 2.191. So in this problem, we wanted to find the mean, the variance, and the standard deviation. The mean was just the average of the different data points. The variance was the average of the squared deviations, and then the standard deviation was the square root of the variance. Now, problem number 2 is a more complicated problem because you're not just given a list of data points, you're given a list of data points as well as how often they occur. So whenever you see frequency information, that means, okay, the data point 1 happens once, the data point 5 happens 3 times, the data point 6 happens twice, the data point 10 happens 2 times. So everything that we did in the previous problem is just a little bit more complicated when we have this frequency information. So let's do an example where we have frequency information. So in this problem, Mrs. Runge's students are teasing her for her silly sayings like chatty people, and I'm going to wait until everyone is listening respectfully and okie dokie. So over the course of 2 school weeks, which is 8 class blocks, students collect data about how often I say okie dokie during class. The data is given in the table to the right. So this means that one time in one of the class blocks, I only say okie dokie once. In 3 of the class blocks, I say okie dokie 5 times. In 2, I say it 6. And in 2, I say it 10. And the question is that we want to find the mean, variance, and the standard deviation for the number of times that I say okie dokie. So to find the mean, it is not as simple as just adding up 1 plus 5 plus 6 plus 10 and dividing it by 4, because there actually aren't just 4 data points. There are actually 8 different data points, and we have to add all of those up and divide by 8. Now, we could sort of figure this out, right? Like there's 1 1, so we have to include 1 once. And then there's 3 5s, so we would have to include 5 3 times. And then there's 2 6s, so we would have to include 6 twice. So you could go like 1 plus 5 plus 5 plus 5 plus 6 plus 6 plus 10 divided by 8. However, the bigger the frequencies are, the harder it's going to be to do that. So basically what we're going to want to do to find the mean is take each of the data points, multiply by how many times that happens, and add all of those up, and then divide by the number of numbers that there are. So we can use our table to help us out a bit. So in the first column, we're going to list off all the different data points we could have. So that's 1, 5, 6, and 10. And in the second column, we're going to list off the frequencies. So 1, 3, 2, and 2. And in the third column, we're going to take the x values and multiply by the frequency of that happening. So 1 times 1 is 1, 5 times 3 is 15, 6 times 2 is 12, and 2 times 10 is 20. So what we're going to want to do is we're going to want to add all these numbers up and divide by the total number of data points that there are. Now, the sum of the frequencies tells you how many data points there are in total. So let's find each of these totals. If we add up this column, we get that we have 8 different data points. And if we add up this column here, we're going to end up having, 48 different data points. So to find the mean, what we're going to do is we're going to take this sum and divide by the number of data points that there are, which is 8. So we get 48 over 8, which is 6. So now that we have the mean, we want to calculate the variance. Now, in the previous problem, we were able to just calculate the deviations, then calculate the squared deviations, and find their average. Here's the problem. When a data point happens more than once, you need to include the squared deviation that goes along with that data point more than once in your calculation. So let's look at the data point 5. Whatever squared deviation goes along with 5, you need to count it 3 times because the data point 5 happens 3 times. For the data point 6, whatever the squared deviation is, we have to count it in our average twice, because the data point 6 happens twice, and so on. So basically what we're going to have to do is not find the average of the squared deviations, but we have to first multiply our squared deviations by our frequencies in order to find our overall average. So let's fill in the rest of the table. So in this column, we want to take the x values and subtract off the mean. So first we have 1 minus the mean. So we would get -5. Then we have 5 minus 6. That would give us -1. Then we have 6 minus 6. That would give us 0. And 10 minus 6. That would give us 4. So after we have our deviations, we can calculate our squared deviations by squaring each of those values. So -5 squared is 25. -1 squared is 1, 0 squared is 0, and 4 squared is 16. Now once again, we can't just find the average of these four numbers, because this squared deviation we want to count once, this one we want to count 3 times, this one we want to count twice, this one we want to count twice as well. So before we sort of do any averages, we need to take each of our squared deviations and multiply by the frequency. So for our first one, we want to do 25 times 1. That makes 25. Then we're going to do 1 times 3. That makes 3. Then we want to do 0 times 2. That makes 0. Then we want to do 16 times 2. That makes 32. So now we're going to add all these up and divide by the total number of data points there are, which was 8. So if we find this sum, we're going to get 60. Now if you notice, neither of these totals were useful to us, so I always like to just sort of color them in and get rid of them. And our variance is going to be the sum of this column divided by the total number of data points there are, which is 8. So our variance is 60 divided by 8. Which is 7.5. And our standard deviation is always just going to be the square root of our variance. And if we take the square root of 7.5, we get about 2.7 39. Okay, so in this problem we actually had frequency information. So our process was a little bit more complicated. We used this table to calculate all the different values we might be interested in. To find the mean, we took this column, the sum of this column divided by the sum of this column. To find the variance, we took the sum of this column divided by the total number of data points there are, and then to find the standard deviation, we took the square root of the variance. And that was it. Now be careful when you're doing these problems to be really careful as you're going through step by step. Just make sure that you're doing the calculations carefully. Some common mistakes are when students go to square their deviations, if they have a negative, you need to put that negative in parentheses before you square it if you're using your calculator, because otherwise the calculator would tell you that -5 squared is a -25 when it should be a +25, because it would just square the number and not the negative. Also, just make sure that you're finding all these sums really carefully. It's really easy to make a computation mistake and have it sort of throw off your entire problem. So just be careful about those things.